Hello? Hello? Okay, ఏంటి ఏడ ప్రాబ్లం ఉంది
కొంచెం సార్ అదే కనెక్ట్ చేస్తున్నాం లేదు.
ఇప్పుడు ఓకేనా? ఓకే, రైట్. తీసుకుంటున్నా.
తీసుకుంటా.
ఓకే, థ్యాంక్ యూ. రైట్. స్టాప్ షేరింగ్ పక్కన హైడ్. ఓకే, 1 minute. కనెక్షన్
ఇదే చేస్తాను సార్.
నా జియో పెట్టి ఉండాలి కదా.
స్లో ఉంది సార్. కనెక్ట్ చేస్తాను.
మా ఇంటర్నెట్ అది అమలు చేయలేదు.
ఓకే,
రైట్. ఆఫ్టర్ 5. ఓకే, 5 తర్వాత మీట్ అవుతాం.
భరత్ గారు, హలో. హలో. ఓకే, good afternoon, my dear students. Welcome to online GATE class on transportation engineering. In the last class, we have seen the detailed discussion on design of flexible and rigid pavements, the entire theory related to the pavement design, and also discussed some of the numerical examples, problems that appeared in previous GATE examination. Let's continue the same topic. The following statements are related to temperature stresses developed in concrete pavement slabs with free edges without any restraint. The following statements are related to temperature stresses developed in concrete pavement slabs with free edges without any restraint. There is no restraint at the ends of the slabs. So now let us look the various points, statements given. The first statement is P. The temperature stresses will be zero during both day and night times if the pavement slab is considered weightless. So now whether that statement is correct or not, now we have to look, because here what is going to happen without any restraint. Without any restraint means the slab is going to move. Slab is going to move. So there is no warping stresses. Warping stresses will come into picture only when there is a restraint. But here restraint is not there, so warping stresses are zero. So other stresses are frictional stresses. You know, in the last class discussion, frictional stresses means W multiplied by F, weight of the slab, weight of the half of the slab multiplied by F will be equal to stress in the concrete multiplied by area of the concrete. Area of the concrete is D into H. This is the equation that you have seen. But when the slab is weightless, W equal to 0, you can look at here weightless. When there is no weight, the weight of the slab, weight is not considered, there is no frictional resistance. When there is no frictional resistance, then temperature stress is also 0. So the statement P is correct. The statement P is correct. Always the weight of the slab is considered. Then only the frictional stresses will come into picture. But here W value is becoming 0. In the statement itself it is given weightless. So when the slab is weightless, no frictional stresses. That means the temperature stresses will become equal to 0. So the statement P is correct. Next Q, the temperature stresses will be compressive at the bottom of the slab during night time if the self weight of the pavement slab is considered. So you can look at here, temperature stresses will be compressive in nature, at the bottom of the slab during the night time, if the self weight of the pavement is considered. So at that case, when the self weight of the pavement is considered, naturally the stresses will be there. The temperature stresses will exist when the weight of the pavement is considered, whether it is during night or day, some stresses will develop. But particularly in the night time, what is going to happen for the slab at the bottom T1, top T2, that means T1 is more than T2. When T1 is more means the bottom part is going to expand more, and it is subjected to a force, compressive forces. Whenever there is expansion, it will be prevented by means of inducing the compressive stresses. So during the night time, bottom temperature is more than the top temperature, and bottom is going to elongate more, and because of this more elongation, it is subjected to compressive stresses. So compressive temperature stress will induce at the bottom, and also weight of the pavement is considered. So statement Q is also correct. Now see the statement R. The temperature stresses will be compressive. The temperature stresses will be compressive at the bottom of the slab during the daytime. So in the daytime, more temperature is at the top, less temperature at the bottom. So T1 is more than T2. When temperature is more at the top is subjected to compressive stresses and bottom is subjected to tensile stresses. Top is subjected to compressive, bottom is subjected to tensile. What is the statement here? Temperature stresses will be compressive at the bottom. At the bottom it is not compressive, it is tensile. It is at the tensile. This is in the daytime. Similarly, it is in the night time. In the night time when the temperature is more, bottom is under compressive stress, top is under tensile stress. So accordingly, the statement P and Q are correct, whereas the statement R is not correct. So the answer is both the statements P and Q are correct. So here, for such a statements are given in the examination, it's very difficult to remember daytime or bottom positive, bottom compressive, top negative, top tensile or reverse. It's impossible to remember all these things. So what you do, you have to analyze it only with the small diagram. You can look at here, this is day, top temperature is more. When the temperature is more, it is going to expand. And when expansion is prevented, then what is going to happen? Compressive stress will induce at the top, and similarly tensile. In that way, you need to understand, you need to answer the question, not by means of remembering such statements. Okay, this is the explanation. You can also have a look later in detail. And the detailed discussion is also given at this statements, statement P, statement Q, and also R. You can see this later. So already I told you for P, what is going to happen? Warping stresses are zero because no restraint. Okay, you can look at whatever the discussion that I told that will cover these concepts. Next one. Select the strength parameter of concrete used in the design of plain jointed cement concrete pavements from the following choices. So in the design of rigid pavement or design of cement concrete pavement, both are one and the same. We are taking into consideration only the flexural strength. We are not taking any tensile strength, no compressive strength, no shear strength, tensile, flexural strength. Flexural strength of the concrete used in the design of rigid pavements. The next one. A pavement designer has arrived at a design traffic of 100 million standard axles. So NS will be equal to 100 MSA, million standard axles. For a newly developing national highway, as per IRC 36-37 guidelines, using the following data. Design life 15 years, N is equal to 15 years. Commercial vehicle count before pavement construction 4,500 A. So that means before pavement construction, at the time of pavement construction it is 4,500. Annual traffic growth rate 8% given. The vehicle damage factor used in the calculation was, the question is what is the F value? So the basing on this, you have some relation for NS. NS equal to 365A 1 plus R whole power N minus 1 by R into F and also multiplied by D. Lane distribution factor is not given, so consider D as 1. And in this NS is known, A is known, R is known, only F is the unknown value that can be found, that is equal to 2.24. So here while observing and while reading all these problems, it may be looking simple, but if you don't have practice of computing F value from this, it's very difficult in the examination. You may need to spend a lot amount of time, or though you know the formula, so how to substitute it, and you may fail in calculating the final value because it is 1 plus 0.08 whole power 15. So it is 1.08 whole power 15. If you have knowledge of this for computing and using calculator, then only you can solve this problem. And majority of the students will fail at this stage of calculation also. So we were practicing of getting this solution is more important. Next one. Consider the following statements in the context of cement concrete pavements. Cement concrete pavements. Warping stresses in cement concrete pavements are caused by the seasonal variation in temperature. Warping stresses. How warping stresses will occur? Warping stresses will occur because of the variation of the temperature from top to bottom. And because of this variation of the temperature, then warping stresses will occur like this. It is not varying with the seasonal. The warping of the slab will occur only because of the change of the temperature across the cross section. So the statement 1 is false. You can read. Warping stresses in cement concrete pavements are used by the daily variation in temperature. Daily variation in temperature only, and variation across the cross section. Next one, number 2. Tie bars are generally provided across transverse joints of cement concrete pavements. Where do you use tie bars? Tie bars will be used along the longitudinal joint, not the transverse joint. This is called the tie bar. So where it is used, the tie bars are used along the longitudinal joint, but not the transverse joint. In the direction of transverse, in the transverse direction, the reinforcement used is called the dowel bars. Dowel bars are in transverse direction, whereas tie bars are in the longitudinal direction. So statement 2 is also false. So answer D. Statement 1 false, statement 2 also false. So for answering all these questions, overall subject conceptual knowledge is more important, not by remembering certain simple points. 14. Which of the following stress combinations are appropriate in identifying the critical condition for design of concrete pavements? So already you have seen the critical conditions for the design of pavements. What are the things here? Type of stresses. One is load stress. Second one is temperature stress. Because of the load, where it will be maximum, which of the following stress combinations are appropriate in identifying the critical condition for design of pavements? So you know that it will be, load. Because of the load, it may be edge, interior, corner also. Because of the load, corner stress will induce, edge stress will induce, interior stress also induces at the interior part. So stress at interior, stress at edge, stress at corner because of the load. And because of the temperature, where do you get the stresses? Because of the temperature, it will occur interior, because the entire frictional stresses will occur exactly at the center of the panel. And that means Q is associated with the 3. Q is more associated with the 3. And look at the options. Q is more associated with the 3 means answer may be either A or B, because the load stresses may be at the corner, maybe at the edge, maybe at the interior. All the 3 possibilities are there. But for the temperature, it is only at the edge and also interior. Whereas at the corner, the value becomes very small. And once you took this P1 means load corner. That is not at all the critical combination. So the other option will be P2. So out of given choices, you need to select appropriate answer for it. 16. It is proposed to widen and strengthen an existing 2-lane national highway. Already 2-lane national highway available as divided highway. Originally 2-lane. Now it is going to be divided highway, and widening is going to be done. The existing traffic in one direction is 2,500 commercial vehicles per day. Existing traffic. The construction will take 1 year. That means here P is 2,500. And after 1 year, the number of vehicles will becomes equal to A. A is the expected traffic at the time of completion of the construction of the pavement after 1 year. The design CBR of soils upgrade is found to be 5%. CBR equal to 5%. The traffic rate growth rate R equal to 8%. Vehicle damage factor 3.5%. Design life N is equal to 10 years. And traffic distribution factor D equal to 0.75. The question is cumulative standard axles computed R. Cumulative standard axles computed R. So since it is in only one direction, compute the NS value also in the same direction, in only one direction. So for that what you do, this is the entire information and find out the anticipated traffic. Anticipated traffic after 1 year. A is equal to P into 1 plus R whole power 1. Now N value is equal to 1 year. Construction will take 1 year. So accordingly 2700. 2700. And basing on this cumulative standard axles NS equal to the formula you know. This is the entire formula that you know. And since it is only in one direction, you can omit this. 2 means both the directions. 2 into 2700. But the question given is in one direction and finally cumulative standard axles also in one direction. So instead of for computing that, either you want to calculate 2, use 2 and later divide it by 2. Or otherwise omit this 2, whatever the value that you got, that will be the correct. So accordingly substitute all, you will get 79.74.94. It is for both the directions. It is for both directions. And for one direction, half of it. If you don't use 2, you will get straight away 37.47. Otherwise use 2 and again find out per lane. It is for 37.47. It's a standard question. Several questions appeared so far of this type. The next one. The following data pertains to the number of commercial vehicles per day for the design of flexible pavement for a national highway as per IRC 37. It is flexible pavement. The type of commercial vehicle, number of vehicles per day, and damage factor also given. So damage factor F given, number of vehicles per day also given. 2 axle trucks are 2000, tandem axle trucks are 200. Tandem axles means 2 axles very close at the rear side of the vehicle. That is called the tandem axle. Assuming traffic growth rate factor 7.5% R value given per annum for both type of vehicles, for both 2 axle trucks and also tandem axle trucks. The cumulative number of standard axle load repetitions for design period of 10 years is, so N is 10 years. So what you do here, you need to find out NS value. NS value is NS1 for 2 axle trucks and NS2 is for the tandem axle trucks. Because damage factor is different, vehicle number is also different, but rate of growth is same and design life is also same. So what you do is you find out NS1 separately for 2 axle trucks, NS2 separately for tandem axle trucks, so that the total value will become the standard number of repetitions for the highway. So what you do, this is the standard formula that you know, and the lane distribution factor is not given. You can use D equal to 1 multiplied by D. And this is the entire information. Now, for the first case, A equal to 2000 vehicles and all these parameters are same, and find out NS1, which is 51.6 MSA. There is no ambiguity here. If you know the formula, if you know how to substitute, if you know how to use calculator, you will get automatically 51.6. And similarly, for the tandem axles 200 and damage factor is 6. And accordingly substitute, and it will be 6.2 MSA. So NS1, NS2, it will becomes equal to 57.8. So here two different types of vehicles are there, two different types of axles. So we are computing the standard axles for axle 1 and also for the axle 2 type of vehicles. Next one. The width of the expansion joint is 20 mm in a cement concrete pavement. That means that is the gap between the slab panels in cement concrete. Gap between the cement panels. So this is one panel and it is another panel. The gap in between these two is, this gap will becomes equal to 20 millimeters. The laying temperature is 20 degrees centigrade. So at the time of laying it is 20 degrees. And the maximum temperature in summer is 60. So that means the temperature is varying from T1 to T2. The coefficient of thermal expansion of the concrete is 10 into 10 power minus 6, alpha is given. Alpha is given. And the joint filler compresses up to 50% of the thickness. 20 mm is the original gap, and the entire gap will be filled by the mastic pads, and mastic pads are going to allow only 50% of the gap. So what is originally delta equal to 20 mm, and what is delta dash? The delta dash, the actual compression or actual movement will be equal to only 10 millimeters. Only 10 millimeters. Now spacing of the expansion joints is, what is the value of L? So you can look at here, delta dash will becomes equal to 50% and it is 10 millimeters. It's a big problem, but nothing is there. Already you are familiar with SM. Delta will be equal to L alpha into T. That's all. L alpha T. And delta is known, alpha is known, temperature difference is known, that is 60 minus 20, and L is the spacing between the expansion joints. You can look at here, L into alpha into 2 equal to delta. So delta 10 mm, L alpha T, and from this 25 into 10 power 3 mm, so it is 25 meters. So gap between the slab panels is now 25 meters. The distance between the expansion joints is 25 millimeters. Don't try to remember any of the formula. This is also the same. It is nothing but delta equal to L alpha into T only. Everything is same. Just use the as simple as possible without much complication. So do not remember any of the formula for any computation of it. Next question. Using IRC 37/1984 guidelines for the design of flexible pavements and the following data, choose the total thickness of the pavement. So the question here is, what is the thickness of the pavement? What is the thickness of the pavement? That is the question. The data is number of commercial vehicles when construction is completed. This is nothing but A, capital A given. Annual rate of growth of traffic or 5%. Design life of pavement N 10 years. Vehicle damage factor F is given. Then CBR is 5%. And data for 5% CBR value, number of standard axles number of standard axles 20, 25, 30, 40, correspondingly 620, 640, 670, 700 mm is the thickness. So here the entire data is given, so that's why the question look like very big. So when the table like this given, when the table like this given, and what is the question? Question is what is the thickness? In the table you can look at the total thickness term. How do you get this thickness? How do you get this thickness? The thickness may be 620, 640, 700, 670. Out of these, one value may be correct. And how to get these values? These values are obtained by observing the number of standard axles. That means MSA. It is nothing but NS. So that means what you do? First find out the NS value. Definitely that computed NS value will become one of these. And if it is one of these, automatically the corresponding thickness will be either 640 or 670 or 610 accordingly. So when the data is more, more observation is required. The question is in one column of your table. When the question is in one column of your table, that answer will be obtained based on the other column of the table. In the other column, what is there? NS. So first find out NS value. And this is the formula and entire data. If you substitute all the values, you will get 30 into 10 power 6 standard axles. That we can call it as 30 MSA. When it is 30 MSA, when it is 30 MSA, it is there in the table. What is the thickness? What is your answer? Your answer will be 670 millimeters. That is this 670 mm. So for that purpose, this table is given, because in the design of flexible pavement by CBR method is based on the number of cumulative standard axles, and accordingly we can compute the thickness of the pavement by the use of curve or graph. But here instead of graph, it has given the values directly, and first compute the NS value, which is 30. Associated thickness will be 670, so 670 is the answer for it. Remember one thing, when the question is big, it composed of diagrams, tables, etc. Your clear-cut observation is more important. If the observation is clear, the solution will be there 50% in it. Next question. In case of governing equations for calculating wheel load stresses using Westergaard's approach, the following statements are met. So Westergaard approach is used in case of wheel load stresses in rigid pavements. Now see the statement 1. Load stresses are inversely proportional to wheel load. Load stress means a sigma is inversely proportional to wheel load. Wheel load is P. Is it correct? Normally in any of the case, the stress is normally proportional to P, or sometimes the stress may be root P or maybe P square, etc. will be there in different cases, but it is not at all 1 by P. Not only this payment, for any of the thing, sigma will never be inversely proportional. And for that purpose, just you can look at here, the critical stress for interior is given by this formula. Already I told you, don't remember this formula. Here now also not required. So it is mainly the stress is proportional to P. Stress is proportional to P, or stress is inversely proportional to H square. Stress is inversely proportional to H square. So the first statement is false. What is the second statement? Modulus of subgrade reaction is useful for load stress calculation. Load stress calculation. Modulus of subgrade reaction. What is modulus of subgrade reaction? K. That K will be used for computing SI. Is it correct or not? Is it correct or not? So what is K? Modulus of subgrade? L will be equal to EH cubed by 12 into 1 minus 12 into K into 1 minus mu square whole to the power of 1 by 4. This is called the radius of relative stiffness. In the radius of relative stiffness, the K term is involved. K term is involved. So that means modulus of subgrade reaction is depending, L is depending on modulus of subgrade reaction. This L is there in the SI equation, the stress computation. Here L, what is this L called? This L is called the radius of the relative stiffness. That means this SI stress at the interior or load stress depends on the radius of relative stiffness. Radius of relative stiffness depends on the K value. So the statement is correct. Modulus of subgrade reaction is useful for load stress calculation. So that is correct. So statement 1 is false and 2 is true. So here the statements are like this. If you read 100 times of the information, you may not get your answer. Only understanding the full concept of the knowledge, then only you can answer all these questions. Next one. The following observations were made of an axial load survey on a load. So axial load 35 to 45 ton vehicles are 800 repetitions per day. So something 35, some vehicle may be 36, some vehicle may be 44, some vehicle may be 45. On an average, with 35 to 45 kilonewton axial load is moving 800 times per day. And similarly 75 to 85 kilonewton axial load is moving 800 times. So repetitions per day on a highway is 400. The standard axial load is 80 kilonewtons. If it is 80 given, you take 80. Otherwise, exactly it is 82 kilonewtons. Equivalent daily number of repetitions for the standard axial load is equivalent daily number of repetitions for the standard axis. The meaning of it will be 35 to 45 800, 75 to 85 400. If it is 80 exactly, what is the corresponding number of the repetitions? So that means for the entire repetitions should be converted into the equivalent value of 80 kilonewtons. Equivalent value of 80 kilonewton axial load, and find out the number of repetitions. So for that, already discussed earlier, axial load is this, and average axial load 40, that is 35 plus 45 by 2, 75 plus 85 by 2 is 80, and repetitions per day 800 given, 400 given, and EALF, equivalent axial load factor. So you know that EALF will be equal to W by W standard whole to the power of 4. So for the first one, it is 40 by 80 whole to the power of 4. So 40 by 80 whole power 4 means 1 by 2 whole power 4, it is nothing but 1 by 16. You can look at here, it is 1 by 16. Similarly, for 80 kilonewton load, the load is 80, standard load is also 80, power 4, it is exactly 1. Because both are same, it is 1. So what is the now equivalent number of standard load repetitions? That means one repetition of 35 to 45 is equal to 1 by 16th of it. Is equal to 1 by 16th of it. So you can look at here. 800 passes are there. 800 passes are there, multiplied by its equivalency factor 1 by 16. 400 passes are there, 400 multiplied by its equivalent value 1, so 450. So that means 450. So that means here 80 kilonewton stresses gives the following values. Analysis of stresses gives the following values. What are the various stresses? One is wheel load stress. These are called the wheel load stresses. And again you can look at another type of stresses, warping stresses. And one more type of stresses are the frictional stresses. So different types of stresses that are induced in concrete pavement with the numerical values are given. So what you have to do, the most critical stress, the worst stress, highest magnitude of the stress is, that is the question. So what is the data? Wheel load stress due to corner of loading. That means whenever, if you want to compute the stress at the corner, you have to consider 30. Otherwise, other value. Wheel load stress due to edge loading. At the edge it is 32. So there is no interior load given. So one is edge, another one is corner. Another one is corner. Next, warping stresses at the corner given during summer. Corner and summer. Corner and winter. Corner and winter. Then warping stress also given edge, summer, edge, winter. Edge, summer, edge, winter. Then frictional stresses during winter. Frictional stresses, first one is during summer, and during winter 4. These are the values given. Basing on this, find out the critical stress. Already you have seen the critical stress combination. There are 3 combinations. One is in summer, another one is in winter, third one is at the corner. In summer, load stress plus warping stress minus frictional stress. Whereas in winter, load stress plus warping stress plus friction stress. At corner, only the 2 stresses, load stress and warping stress. No frictional stress induced there. So these are the 3 different combinations already discussed, and basing on that, substitute appropriate values. The following originally 3 cases, but different data given more, we can see all possible cases. So during summer, critical combination of the stress at the edges. What is the critical combination? One is wheel load stress, warping stress minus frictional. So you can look at here, wheel load is 32. We are using 32. And regarding the warping, at the edge in summer 8. At the edge in summer it is 8. And frictional in summer it is 5. So use those 32, 8, 5, and it is the value. This entire thing is nothing. It is nothing. In summer, already I told you, wheel load stress, warping stress minus frictional stress, and appropriate values you got 35. And during winter, one is wheel load, warping, frictional. You just go back and see. Wheel load 32. Wheel load stress is same because whether it is winter or summer, once the magnitude of the wheel is fixed, the stress developed in the pavement is same. There is no there is no difference whether it is summer or winter. Summer or winter, it is only for the warping stress and also the frictional stress. So in this particular case, 32 is the load stress, and winter warping stress at the edge region, winter is 6. Frictional stress during winter 4. So 32, 6 and 4 are to be used. So you can look at 32, 6 and 4. Once you are perfect in all these things, you will simply use only this last statement. You need not write all these things in the examination. It is only for the understanding purpose. So 32, 6, 8, it will becomes 42 kg per cm square. And another one is at the corner. At the corner. Third one is at the corner. But at the corner also, it is there in summer, it is there in winter. Two different values are given in summer and winter, and accordingly, at the third combination is only corner. That's all. Only the corner. Here in the corner, it may be in summer, it may be in winter, whichever gives the worst value. So what is the corner stress? Corner stress is load stress plus warping stress only, and that too it is summer. So that too it is summer. So you have to take this 30, and also warping stress at corner in summer is 9. So that is 30 plus 9, which is equal to 39. And corner in winter it is 30. 30 is the load stress, and in winter what is the warping? It is 7. So 30 plus 7, 39. So this is the third case. In the third case, you can have A and also B, and by observation the first value is fixed. Only the second value varies, and whichever is more, that will be taken as the combination of the worst case. So second one is 37. You can look at here, one is 39, another one 37. Out of all these 37, 39 and 35, 42. So what is the critical? Critical stress will become 42 kg per cm square, and that will be the appropriate value. So here the data may be anything, but as per your requirement, you have to see what is the statement 1, what is statement 2, and what is statement 3. These are the only 3 critical combinations that occur. 3 critical combinations that occur. Next one. The data given below pertaining to design of a flexible pavement. Design of a flexible pavement. Initial traffic 1213 CPVD. Traffic growth rate 8%. Design life 12 years. Vehicle damage factor 2.5. Distribution factor 1. The design traffic in terms of million standard axles to be catered would be. So with just substitution of various values, and nothing is special here. This is the formula. Substitute everything, you will get the appropriate value. No much discussion is required. Next one. In the context of flexible pavement design, the ratio of contact pressure to tire pressure is called rigidity factor. Rigidity factor is nothing but contact pressure by tire pressure. This factor is less than unity when the tire pressure is. So already you know that tire pressure is less than 7 Newton per mm square. Sorry, 7 kg per cm square. What is going to happen? Contact pressure is more than tire pressure. or otherwise you can write tire pressure is less than 7 means tire pressure is less than contact pressure. Okay, anyway, here it is there. So, average tire pressure. This tire pressure is equal to exactly 7, rigidity factor is 1. Tire pressure is less than 7, tire pressure less than 7, so tire pressure is less than the contact pressure. Tire pressure is more than 7, then tire pressure will be more than contact pressure. Accordingly, you have to answer this particular question. So what is going to happen? This factor is less than unity. When you will get less than unity will occur when it is more than 7 kg per cm square or otherwise 0.7 Newton per mm square. So now normally we have studied already 7 kg per cm square. It can be written as 0.7 Newton per millimeter square, and associated diagram also given. Already it is there in the study of the theory. Now, the plate load test conducted with a 75 centimeter diameter plate on soil subgrade yielded a deflection of 2.5 mm under a stress of 875 centimeter. Deflection is 2.5 mm and stress is 800 Newton per cm square. The modulus of elasticity of subgrade is. So here modulus of elasticity of subgrade. So modulus of elasticity of subgrade is 25 mm and it is 2.5 mm, so 0.25 centimeter, and stress is in Newton per cm square, and see that all the units are in the same type. So 1.18, 837.25, it will be finally Newton per centimeter square. The answer is in kilonewton per centimeter square. Accordingly, convert it. So answer is the modulus of elasticity of the subgrade soil in kilonewton per centimeter square. So whatever the value you got from your calculation, convert it into kilonewton per cm square ultimately, and that will be 141.6. Next. Temperature stresses in concrete pavements may cause the slab to crack. So whenever the stresses are more than the critical, more than the limit, then naturally the slab gets cracked. If a slab cools uniformly, then the crack will develop at the following locations. So here what is going to happen, there is one slab, this slab is going to cool uniformly, temperature is continuously decreasing. Then where do you get the crack? Warping stresses and frictional stresses will develop. But here what is going to happen? If a slab cools uniformly, here it is given uniformly means from top to bottom, from one edge to the other edge. At all edges, it cools uniformly. Whenever it cools uniformly, there is no warping induced. Only when it is going to compress it, what is going to happen? This is going to reduce its length. Because of the reduction of this length, that means it is coming towards the center. What is going to happen? Frictional stresses will develop at the bottom in this direction. And frictional stress will be maximum at the center. because the concrete slab cools completely, and it is going to reduce its length. In the process of reduction of its length, there is a constraint that is frictional resistance developed below the pavement slab and the subgrade. So when it is coming towards center, the frictional stresses will induce in the opposite direction, so that the entire slab is under tension. And where the maximum stress occur, the cracks will occur at the point where the stress is maximum. So these frictional stresses are almost corner, zero at the corner, and at the edge it is very small. And as it is moving towards this up to here, this is the maximum. Similarly, in this direction also, what is going to happen? The slab is going to reduce its length. In the process of it, the tensile stresses will induce. So that means about the center, on one side tensile stresses, other side also tensile stresses. So the middle part of the section is under tension. When the middle part of the stress is under tension, maximum stress induced at the center. So if at all crack induced, that will develop at the center of the pavement section. Center of the pavement section. In a concrete pavement, temperature stress is tensile at bottom during daytime. During day. So daytime, temperature stress is tensile at the bottom during daytime. Another one is load stress is compressive at bottom. Load stress is compressive at bottom. So what is going to happen when the load is acting? It is going to take the shape like this. Because of the load it is acting. So bottom is under top is under compression, bottom is under tension. What is the statement 2? Load stress is compressive at bottom. No, load stress is tensile at the bottom. Next one, okay, it's a routine problem. The average daily traffic on a stretch of road, 300 commercial vehicles per lane per day. Commercial vehicles per lane per day. Design repetitions for 10 years when vehicle damage factor is 2.5 and traffic growth rate is. So what is that you need to find out? The average daily traffic. The average daily traffic in terms of cumulative standard axles. And you know the formula, just substitute to the various values and get the right answer. Then dual bars in concrete pavement are placed. Where do you place the dual bars? This is the concrete pavement along the length, and this is the transverse joint. Dual bars will be provided here. Dual bars are provided across the transverse section. So across the transverse section, how it can be represented? Dual bars can be placed across the transverse section. This is one answer. Across the transverse section, and this is in the direction of traffic. You know, traffic is this direction that we can consider as along the direction of traffic. The bar length is placed on the direction of the traffic, or otherwise it will be provided across the transverse section. And you can see the other things also. Perpendicular to the direction of traffic. No, perpendicular to the direction of traffic means like this. So these are the bars, tie bars that are provided. Tie bars are always perpendicular to the direction of traffic. And see, along 45 degrees, no. Can be placed any direction? No. So it is along the direction of the traffic. Next one, the radius of relative stiffness. The radius of relative stiffness for a 20 centimeter thick slab, H equal to 20, with E equal to 3 into 10 power 5 kg per cm square, modulus of elasticity, and Poisson's ratio mu 0.15. Resting on a subgrade having modulus 5 kg per cm cubed is. So the question is, what is the radius of the relative stiffness? If you are able to remember this formula, then only you can solve this. Otherwise, you cannot solve this question. It is whole power 1 by 4. EH cubed by 12k into 1 minus mu square whole power 1 by 4, and you will get 79.98 centimeter is the radius of the relative stiffness. It is CBR, that we will see. Okay. The minimum value of CBR required for GSB, granular subbase, as per most Ministry of Surface Transport specification is 20. So minimum value is 20, that you need to remember. Then the standard size of plate bearing test for finding modulus of subgrade reaction is. For finding the modulus of subgrade reaction, we are using 75 centimeter diameter plate. A two-lane single carriageway, single carriageway means no divider, that's the meaning. So two-way means this is two-lane single carriage means it reads like this. So two-way, we can call it as two-way. Two-lane single carriage means two-lane two-way is to be designed for a design life period of 15 years. N is 15. The total two-way traffic density in the year of completion of construction is expected to be 2000 commercial vehicles per day, that is A. Vehicle damage factor 3. Lane distribution factor 0.75. Assuming an annual traffic growth as 7.5%, the design traffic expected as cumulative number of standard axles is a routine problem. So it means million standard axles. Meter diameter, the elasticity is not 20. You know the formula, what is the value of the ES. Next one. What is the equivalent single wheel load? Equivalent single wheel load, that means ESWL. What is the equivalent single wheel load of a dual wheel assembly carrying 20,440 newtons each? So there are two tires, each one is P, this is P and it is also P, each is acting 20,440 newtons. It is also 20,440 newtons and two are very close to each other. Dual wheel assembly. Pavement thickness is 20 centimeters. So thickness is given. Then center to center spacing of tires 27 centimeters. S is given. And the distance between the walls of the tires. Walls of the tires means the clear distance. D is given 11 centimeters. So what is the equivalent single wheel load? That's the problem. Now what you do? There are important points at D by 2. At D by 2, the equivalent single wheel load will be equal to P. That is up to D by 2. And another one is beyond 2s. Beyond 2s, the corresponding ESWL will becomes equal to 2P. And in between these two, interpolate the value. Interpolate the value. That is the original thing that you have seen. Now, you know, P and D by 2, P D by 2, and 2P 2S, 2P 2S. So these are the coordinates. This is one coordinate A, and these are this is another coordinate 2PS. So what is the question here? The thickness of the slab is 20 centimeters. Where do you get equivalent load? The equivalent load for 20 centimeters, each for pavement thickness of 20 centimeters. What is D by 2? D by 2 means 11 by 2, 5.5. And what is 27 into 2? 54. So one is 5.5, another is 54 centimeters. So this 20 centimeters is in between 5.5 and 54. 5.5 and 54. So we have to go for interpolation. In the interpolation, what you do? For 20 centimeters, you need to find out this. So it is nothing but log of Q. That Q is nothing but ESWL. So log of Q equal to, you have to find out that. The starting value, what is that starting value? Log of P or log of 2440 plus the vertical difference of the two. What is the vertical difference? 40,880 log of 40,880 minus log of P divided by log of 2S minus log of D by 2. Log of D by 2 into the difference between these two. What is the difference? Log of 20 minus log of 5.5, and you will get this. So here log Q equal to something. And what is Q? So here the major problem is, now already theory is over, whether it is log 10 or log E. Which one is correct? So here, so all terminology is associated with the log. All parameters are associated with log. So whether computing is basing on log 10 or basing on log E. So in this problem, all are basing on log E only. All are basing on the log E only. Because for any of the calculations, natural log will be used for anything. And for the special thing, if you want to convert it into base 10, it is multiplied with the 2.303 and you will get log 10 base. Otherwise, all these parameters, everything is must be in terms of log base E only. Base course is used in the rigid pavement form. Why base course is used? Mainly several things are there. One is preventing pumping. That means what is going to happen for the rigid pavement? This is the rigid pavement. The base course is required. Base course means one more thing. It is a PCC and then original concrete. The original concrete. And below this it is base course. Below this subbase. So the main purpose of it, if there is no PCC, what is going to happen? If the concrete is laid directly on the soil, if the concrete is laid over directly on the soil, what is going to happen? Because of the accumulated water at the bottom, there will be some pressure and pumping of the mud will take place. So mud will penetrate into the concrete and it will come up. Because of that reason, we need PCC below it. Not only that, several other reasons are there. One is to provide a strong support layer, to provide capillary cutoff preventing the damage of mud pumping. Otherwise, small pores will be there in the concrete. The mud will come up through the pores. to reduce the thickness of the required cement concrete slab, to increase the service life of. These are the various reasons, and one such reason out of these is C is correct, to prevent pumping, mud pumping. So you can look at prevention of subgrade settlement. Subgrade settlement does not depends on it. Prevention of slab cracking, no. Preventing thermal expansion, no. So only this is the reason, and several other reasons also given here with a clear explanation. Okay, it's also similar. The modulus of subgrade reaction is obtained from the plate bearing test in the form of load deformation curve. The pressure corresponding to the following settlement value should be used for computing modulus of subgrade reaction. For modulus of subgrade reaction, what is the pressure corresponding to 1.25 mm. Pressure corresponding to 1.25 mm or otherwise 0.125 centimeters. So when the plate penetrates into the subgrade by an amount of 1.25 millimeters, the corresponding pressure is called the modulus of subgrade reaction. The width of the expansion gap 2.5 centimeters, delta is given in a cement concrete pavement. The spacing between expansion joint for maximum rise of temperature 25 degrees centigrade. So T is given, T 25. Assuming coefficient of thermal expansion alpha given, coefficient of thermal expansion alpha is given per degree centigrade. So already you know that we are assuming that 50% of the mastic pad is going to compress. So the allowable deformation is only delta by 2, that is 1.25 centimeters. And already you know the formula, delta dash equal to L alpha T. Substitute everything and get the L equal to 50 meters. The total thickness of pavement by CBR method depends on the CBR value of. How do you get the total thickness of the pavement by CBR method? It is by means of the CBR of all layers, because CBR for top layer may be more, but it requires CBR for the lower layers also. The total thickness of the pavement depends on CBR value of the surface course, base course, and also subgrade, all different types of layers that are there in the cross section. Group index of a soil is 7. The subgrade soil is rated as. So already in the last class the small table is given regarding the group index. The minimum value is 0 and maximum is 20, and accordingly 0 to 1, 2 to 4, etc. More is the group index value, poor is the material. And as the group index is less, that is the good material. And this is appropriate values, and you can say accordingly poor, very poor, good, and fair. Since the moisture content at the bottom of a rigid pavement slab is generally more than at the top. Since the moisture content at the bottom of the rigid pavement slab is generally more than at the top. More than at the top. What's going to happen here? The moisture content at the bottom of the rigid pavement is generally more. So here moisture content is more at the bottom than the top. The bottom of the slab is generally in tension. Of course, it is general, not we know we should not say always tension. Generally, it is tension because the because of the wheel load, it is going to deflect like this. Bottom is under tension, top is under compression. Top is under compression. Flexible pavements derive stability primarily. How do you, flexible pavements gets the stability? It is only by means of the interlocking and by developing the friction and also cohesion. The load transfer is by means of the grain to grain distribution. Grain to grain distribution. So there the friction and also cohesion will affect, and aggregate interlocking also will have predominant role. Then of course 1.25 mm. It's a routine question already you have seen. For modulus of subgrade reaction, the settlement to be used is 1.25 mm. Then a plate bearing test was carried out on subgrade using 76 centimeters diameter rigid plate. The deflection of 1.25 mm was caused at a pressure of 0.84 kg per cm square. The modulus of subgrade reaction is, actually the modulus of subgrade reaction is basing on the 75 centimeter diameter plate with 1.25 mm deflection. The pressure is called the K. Pressure is called the K. But here the plate is 76 centimeter. So what you do first with D1 delta P, find out K equal to P by delta. That is 0.84 by 0.125 as per the given values. And this is the modulus of subgrade reaction. This modulus of subgrade reaction is for 76 centimeter diameter plate. But what is the standard value? Standard value is 75 centimeter. And you know the relation Ka equal to K1A1, and substitute here, you will get this is the final modulus of subgrade reaction. Correct modulus of subgrade reaction. So here we are correcting for the diameter of the plate. Correcting the diameter of the plate also in this particular problem. The contraction joint is provided in concrete to prevent contraction of the pavement. Okay, you can look at all this. In a cement concrete pavement, dowel bars are used in expansion joints only, and that joint also in the transverse direction. The load transfer to lower layers in flexible pavement is by means of grain to grain contact in case of flexible pavement. The modulus of subgrade reaction is evolved from. So which of the following test is will be used for modulus of subgrade reaction? So sometimes you may feel that all these tests are you know everything but unable to answer it. So in such a case, modulus of subgrade means you have to understood that there is a plate and some pressure will be exerted on it, so that the deflection equal to 1.25 millimeters, and naturally that is possible in case of plate bearing test. And these are the various tests used for different purposes. Plate bearing test is for modulus of subgrade reaction. CBR test is the relative strength of the pavement material. Direct shear test is for the finding C and phi parameters. Triaxial test also used for C and phi parameters. So you have to observe each and every one. Otherwise, you may not answer the questions that will come later. Next, the position of the base course in a flexible pavement. Sometimes such a simple questions will be there. You can see the here soil subgrade, then sub-base course, and surface course, where it is lying. It is above the sub-base course, above the sub-base course. So that's all about various questions appeared in GATE, and let us have a look about various previous Indian Engineering Services questions also, because those questions also standard. Giving only few questions related to this, not covered in previous topics, and it may cover in future. Consider the following data with respect to the design of flexible pavement. Design wheel load 4200, tire pressure 0.6 kg per cm square, elastic modulus 150 kg per cm square, permissible deflection 0.25 centimeter, and in the examination it also given pi power half 1.77 because calculators are not allowed for that exam, and pi power minus half equal to this, 1 by pi equal to this, pi square equal to this, so that calculation is easy. The total thickness of pavement for a single layer elastic theory will be nearly. Single layer elastic theory nearly. So this is the entire data given, but this is the formula for the single layer theory. Thickness will be equal to 3p by 2 pi es delta whole square by minus a square. A is the radius of the contact, and that will be pressure equal to p by pi s pi d square a square pi r square. So p by area. So area means pi r square. Pressure, everything is known. You can find out the small a value. Small a is not known, and p is known. Modulus of velocity is known. Delta is known, and substitute all the values here. The thickness of the pavement directly 51.3 centimeters. 51.3. Already observed this formula earlier, but I told you that don't remember this. Sometimes the questions may appear basing on that, but GATE examination is not with the by-hearted formulas. Okay, anyway, if you are capable of remembering this, you can otherwise neglect it. The revised CBR design method recommended by IRC for design of flexible pavement, the total thickness depends on. So in the CBR method you have seen the total thickness depends on the CBR value and also NS. In the previous problem we have seen for CBR is equal to 5% and NS will be equal to 20, 30, 35, 40, and accordingly the thickness is given. Accordingly thickness is given 620, 670 something given. So that means how the entire CBR method of design depends. CBR method design depends on CBR equal to 5. Because if the CBR value is different, accordingly the thickness of the pavement also different. So it depends on the thickness, depends on the three parameters. One is CBR, then NS value, and these two parameters are used for computing the thickness of the pavement. So what is the answer? The CBR value of the soil and cumulative standard axial loads, NS. So already you have some base knowledge by reading some of the numerical questions and also at the time of theory, and basing on that you need to analyze yourself for answering this type of question. Here you can look at only CBR value. So only CBR value, there is no question of determining the thickness. And CBR value magnitude of wheel load, that is not the case. And here number of commercial vehicles passing, no. Number of commercial vehicles passing is not the correct, and computing the standard cumulative axial loads. Then what is the critical thickness of pre-stressed concrete pavement? Critical thickness of pre-stressed concrete pavement using Westergaard's corner load formula. using Westergaard's corner load formula to support maximum wheel load of 4,200 kg. Allowing 10% for impact, tire pressure may be taken as 7 kg per cm square. Assume flexural strength of concrete as 50 kg per cm square. Factor of safety as 2. Subgrade reaction for plastic mix road as 6 kg per cm cube. And modulus of elasticity 3 into 10 power 5 kg per cm square. So here you need to find out by using Westergaard's corner load formula for the thickness of the pavement. For the thickness of the pavement. This is the entire data given, and Westergaard's corner formula is this. Already in the last class I told this, I have given this formula, but I told don't remember this. You can still don't remember this. If such a question appear in the GATE examination, they will provide you this formula. They will provide you this formula. Only thing you need to understand how to substitute and what are the various parameters. Don't by heart all these formulas, but whenever such a questions occur, you need to substitute appropriate values. That is more important here. The next one, what will be the initial traffic? What will be the initial traffic after construction in commercial vehicles per day for the following data? Annual average daily traffic at last count is 400 CVD. Last count means it is P. And when the traffic, after construction of the traffic, the number of commercial vehicles is A, and that will be the question. What will be the initial traffic after construction? After construction, the value is anticipated number of vehicles after completion, that is A. And 400 is given as P, and rate is given R. Road proposed to be completed in 3 years. So that means the road is going to complete in 3 years. So you know the formula A equal to P into 1 plus R whole power N. It is just like that compound interest. It's just like compound interest formula. That is 400 into that you will get 490. That's all about it. 490 commercial vehicles a day. In a flexible pavement, the vertical stress decreases, vertical compressive stresses decrease with the depth of the layer. Yeah, that is correct. As depth is more, the magnitude of the compressive stress is going to reduce. Option B, the vertical compressive stress is the maximum at the lowest layer. It is not correct. Tensile stresses get developed. In flexible pavement, no tensile stresses induced. Maximum stress induced by a given traffic load is independent of the location of the load on the pavement surface. Maximum stress induced depends on the location of the load on the pavement surface. No, whatever may be the pavement surface, it is one and the same. Then, what is the deflection at the surface of a flexible pavement due to wheel load of 40 kilonewtons and a tire pressure of 0.5 MPa? The value of E for pavement and subgrade is 20 MPa. What is the deflection at the surface of a flexible pavement? So delta is to be found. So in case of flexible pavement, you know this formula. 1.5 P into A by ES. 1.5 P into A by ES. So here what is going to happen? The value of E for both the pavement and also subgrade is 20. For both it is 20. Contact pressure, contact area A equal to wheel load by tire pressure. Both are given. So you will get the contact area. Once contact area is known, that is nothing but the pi A square, where A is the radius of the contact area. And A will be given 159.6. So what is that you want? PAES, delta. So delta is the requirement. Delta is the requirement. P already given, 1.5 constant, P is given, and now A value computed as 159, and ES given 20. F, it is a factor that is to be used for the layered pavement. But here both the layers are having same magnitude of the modulus of elasticity. So it is 5.996 millimeters. So here A value is not directly given. Instead of that, it is given the axial load, wheel load, and also the tire pressure, and accordingly you can find out the contact area. Based on the contact area, radius of the contact area can be found, and substitute that you will get the deflection of the surface of flexible pavement. Next one, the corrected modulus of subgrade for standard diameter K1 D1 equal to K2 D2. So K1 is not known, K1 into 30 equal to K2 multiplied by 75, and accordingly you can find out the modulus of subgrade reaction for any diameter of the plate using this simple relation. Next, of course, this is in the next chapter that we'll take up later. Yeah. The subgrade soil properties of a sample are as follows. Subgrade soil properties. Soil portion passing through 75 micron sieve, 0.075. 0.075 mm sieve is 50%. And liquid limit 40, plasticity index 20, the group index is. You know this is the formula. You have to remember this formula, no other go. 0.2A, 0.005 AC, 0.01 BD. And you should understand what is A, B and C. A is the percentage of the material passing through 75 mm, passing through 75 microns in excess of 35. In excess of 35. How much is passing? 50. So 50 minus 35. So that means above 35, how much is the value? That is called A. Percentage of the material passing through 75 micron sieve in excess of 35. In excess of 35. So from that value deduct it to 35, 15. What is the maximum value? Maximum value is 40. Similarly, B means percentage of the fraction passing through 75 micron in excess of 15. In excess of 15. In excess of in excess of 15. Okay, something wrong here. It is 35. In excess of 15, so that it is 35. And C is the liquid limit in excess of 40. C is the liquid limit in excess of 40. Already liquid limit is 40. So 40 minus 40, it will become 0. And D is the plasticity index in excess of 10. Plasticity index in excess of 10. So 20 minus 10 it is 10. So substitute all these values, then you will get it as some 6.5. It is normally varying between 0 to 20. In a concrete pavement during summer, at noon after midday, the combined stresses at the interior of the slab is equal to. In summer, already you know the equation already discussed several times. Which one of the following sets of factors is related to design of thickness pavement by Westergaard method? So, how do you get the thickness of the pavement? So thickness of the pavement will be obtained by knowing the relative radius of the relative stiffness and also modulus of subgrade reaction. Swelling index, no. And bulk modulus, no. These are no. Deflection factor, no. Traffic index, no. CBR value and stiffness index, no. So for computing the thickness of the pavement, radius of the relative stiffness and also modulus of the subgrade reaction. For conditions obtaining in India, at which location in a cement concrete pavement will the combined stresses due to traffic wheel load and temperature have to be critically checked during design. Where do you check? Where do you check all this? It will be checked normally at the corner, edge and also interior. At the corner, edge and also interior. But the maximum critical cases for Indian case, you will get corner also edge. In one of the numerical problem also, you have seen only the corner stresses and also the various stresses at edge. At interior also it will come, but some worst critical case also come to interior. But majority of the cases, conditions in obtaining in India, and these are the two prominent places where the critical stresses will occur. Radius of relative stiffness of cement concrete pavement does not depend on which of the following. Radius of relative stiffness means L will be equal to EH cubed by 12K into 1 minus mu square whole to the power of 1 by 4. So is there any term load? You can see modulus of subgrade reaction. It is there. So answer is not correct. Then wheel load. Is there any term wheel load? No. So that is the answer. And modulus of velocity of cement concrete. You know, modulus of velocity is also there. Poisson's ratio is also there. So in this way, you need to answer such questions. Without knowing this formula, you may not answer this question exactly. Then, which of the following methods used in design of rigid pavement? In design of rigid pavement, it is always Westergaard method. All the stress computations SI, SEH and also S corner will be computed based on the Westergaard's analysis. IRC code number 37 deals with which of the following? Design of flexible pavement taking CBR and also cumulative number of axles into account. Design of flexible pavement means finding the thickness. The thickness is based on the NS value and also the CBR value. And what are the maximum value of CBR and minimum value of group index for any material? So here CBR means percentage of the fraction strength when compared to the standard aggregate, and maximum possible is 100%. For the aggregate, standard aggregate, CBR is 100. And group index, this is maximum. For group index, the minimum value will become equal to 0. So answer is 100 and also 0. And okay. So this will be seen later, next chapter. And of course, it is pressure corresponding to 1.25 mm. The mixed design of pavement concrete is based on flexural strength. Okay. So these are the questions that you can look at. Repetition. CBR value means measure. It is measured to indicate relative strength of pavement material. The original strength is aggregate. So aggregate is having CBR will be equal to 100%. And when compared to that, we are calculating the strength of pavement material. So that is called the relative strength of the pavement material. Relative with respect to CBR equal to 100 for aggregates. And of course, these are the routine questions. Modulus of subgrade reaction, of course, it is same as the previous one. KD equal to K1 D1, and accordingly you can find out the any other unknown parameter. In cement concrete pavements, tie bars are installed. Tie bars are installed for the longitudinal joint. Then, if the load, warping and frictional stresses in a cement concrete slab are 210, this is the load stress, warping stress, frictional stress. The critical combination of the stresses during summer midday. It is only one combination asked. What is one combination? In summer means load stress, warping stress minus frictional stress. That's all. You need not go for the three different types of stresses. Simply 210, 290 minus 10, it will become 490 Newton per mm square. As per the latest IRC guidelines for designing flexible pavement of CBR method, the load parameter required is, the load parameter for CBR method is the cumulative standard axles only, not the equivalent single axial load, not the number of commercial vehicles, not the number of vehicles, all types during the design life. It is, we are computing the cumulative standard axles only. The general requirement in construction of reinforced concrete road is to be placed a single layer of reinforcement. For example, if at all reinforced concrete is to be provided, normally the CC pavements will be provided without any reinforcement. If a single layer of reinforcement is to be provided, that reinforcement is to be provided at the middle of it. So at the middle of it, the reinforcement purpose, as would be calculated with the static wheel load. So normally with the static wheel load, we can go for the design, and by considering the impact effect also into account, the thickness of the slab will be increased, and not the other options. Providing for the purpose of impact, providing base course, there is no use of it. Adopting a reduced flexural strength of concrete through a factor of safety, no. adopting increased stress relative to that produced by the static wheel load. So only alternative is increase the thickness because of the consideration of the effect due to impact. The plasticity index of the fraction passing through 425 micron ISCU in case of sub-base or base cores should be less than 6. Should be less than 6. And of course, it's a routine question. So these are the various parameters given R, E, K, etc. The combination of parameters required for obtaining radius of relative stiffness of cement concrete is. What is the radius of relative stiffness? You know, EH cubed by 12K into 1 minus mu square whole power 1 by 4. So you can look at E, H, K and mu. All these are the parameters. But you can, if you see the option A, E, K, mu, V, it is not there, R is not there. And R is not there, here also R is not there. Like that. And these are the various parameters associated with the radius of the relative stiffness. So I think with this we can conclude today because already time is over. With this entire flexible payment and also requirement analysis and design completed, and in the next class tomorrow we'll switch over to the pavement materials. So today, thank you very much for listening. Thank you.